Welcome to the channel. In this video, we are discussing about the radical center concept in the system of circles. What is radical center? Suppose three circles are given. The number of circles are 3. Find the radical center of 3 circles whose centers are non-collinear. The 3 circles centers are non-collinear. How to find the radical center of 3 circles? Now discussing here, the solution is, take first the given circles. So given that the circles are x square, suppose that s is equal to x square plus y square plus 4x minus 7 is equal to 0. So this is first one. And second one is here, so s dash is equal to 2x square plus 2y square and plus 3x plus 5y minus 9 is equal to 0. This is second actual. But here, while finding the radical center, you have to observe that the given 3 equations are in the general form of the equation of circle or not. What is general form of the equation of circle? We have that is x square plus y square plus 2gx plus 2fy plus c is equal to 0. If you observe here, first equation is in the form of x square plus y square plus 2gx plus 2fy. F coefficient is not there, okay, but constant is there, minus 7 is equal to 0. But here, the second one, so it is not in the general form of the equation of circle. So when it is not in the general form of the equation of circle, you have to transform it is into the general form of the equation of the circle. So how to transform this is, so here by dividing by coefficient of x square here throughout equation, we get that is s dash is equal to now, so it becomes x square plus y square plus, when you divide by 2, 3 by 2 into x plus 5 by 2 into y and minus 9 which is equal to 0. Now instead of this, you take this one as the second equation, right? So once if you take like this, the third equation is already, it is in the form of circle equation. You take that s double dash is equal to x square plus y square plus y is equal to 0. So which is directly, it is in the general form of the equation of the circle. Once after confirm that, so the given equations are in the general form of the equation of the circle. So what is radical center? So radical center is the, suppose here 3 circles are there whose centers are non-collinear, like these 3 circles are there. What is the radical center? This is s dash is equal to 0, here s dash is equal to 0, and this is s double dash is equal to 0. So here whose centers are non-collinear, C1, C2, C3 are their centers suppose. So then how to find the radical center? So before going to find the radical center, you have to find the radical axis of each pair of circles. You have to find the radical axis. This is radical axis. So radical axis of each pair of circles we have to find. So radical axis of s is equal to 0 and s dash is equal to 0, and radical axis of s dash is equal to 0, s double dash is equal to 0, and radical axis of s dash is equal to 0 and s triple dash is equal to 0. So here the point of concurrence of radical axis of each pair of circles is concurrent. Those are all radical axes are concurrent only. So that point of concurrence is called, this point of concurrence, that means point of intersection of radical axis is called the radical center. Suppose this is radical axis L1, here L2 and here L3. If you take like that, now what I am doing is, the point of intersection of radical axis is radical center. So that's why first I am finding the radical axis of so pair of the first 2 circles, that is pair of circles s is equal to 0 and s dash is equal to 0. So the radical axis of 1 and The radical axis of 1 and 2 is s minus s dash is equal to 0. The radical axis of 1 and 2 is what? S minus s dash is equal to 0. Now which gives, so s is here x square plus y square plus 4x minus 7 and minus of s dash is here x square plus y square. So plus 3 by 2 into x and plus 5 by 2 into y minus 9 is equal to 0. So see here, now here x square, y square, minus x square, minus y square are gets cancelled. So we get here 4x minus 7 and minus 3 by 2 into x and minus 5 by 2 into y and here plus 9 is equal to 0 we get. Now by taking the LCM we get here, LCM is 2 here. Suppose here when you divide by 2, this is also 9 by 2 you have to do. Here also constant is also you have to divide by 2. Throughout equation you have to divide by 2. So that's why this also becomes 9 by 2. So here carefully you observe that this is also minus 9 by 2, here also minus 9 by 2. When you take the LCM here you get, so this is 8x, this is 8x and here minus 14 and here this is minus 3x, here minus 5y and here plus 9 is equal to 0. Plus 9 is equal to 0. So now finally we get 8x minus 3x is 5x and here minus 5y and minus 14 plus 9 is minus 5 which is equal to 0. So further if you reduce this is, it becomes x minus y minus 1 is equal to 0. So this is the fourth equation, suppose if you say. So radical axis of 1 and 2 we found. So further what you have to do, you can find the radical axis of either 1 and 3 or 2 and 3 also. Now I am finding the radical axis of 1 and 3. Why? Because so again to avoid the fractions here, radical axis of 1 and 3 I am doing. So 1 and 3 is which is s minus s double dash is equal to 0. So s minus s double dash is equal to 0. So now here we get, so what is the equation of here s is equal to 0. See here, s is equal to 0 equation is what here, x square plus y square plus 4x minus 7 is equal to 0. So which gives x square plus y square, so plus 4x minus 7 and minus of, the third equation is we have circle equation, x square plus y square, x square plus y square plus y is equal to 0. So further here again x square, y square are gets cancelled, here minus x square plus x square and here minus y square plus y square. Finally we get here, this is 4x and here minus y and here minus 7. So I am writing directly here 4x minus y minus 7 is equal to 0. 4x minus y minus 7 is equal to 0, which is the equation 5. Now what I told you, radical center. See, radical center is equal to radical center which is equal to the point of intersection of radical axis. What are the radical axes? So equation 4 and equation 5. So a point of intersection of 4 and 5. So which is the radical center, point of intersection of radical axis. Now solving 4 and 5 here, solving the condition, the equation 4 and 5. So which is only the point of intersection of 4 and 5 is the radical center. So that's why here x, y, 1, solving this by cross multiplication method we get minus 1 here. So minus 1 and again 1. So minus 1. So here minus 1. So minus 7 and coefficient of x is 4 and again minus 1. So now therefore x is equal to, if you multiply these two, we get, so this is 7 and here minus 1 by here to get the x value here minus 1 and here plus 4. So which is equal to 6 by 3, which is equal to, we get 2. Similarly, finding the y value here, y is equal to minus 4, this is minus 4 and plus 7 by again minus 1 plus 4, which is equal to 3 by 3, which is equal to 1. See, this is only the, therefore radical center is equal to, radical center is equal to, so point of intersection of radical axis, which is equal to, so 2, 1. So this is the final solution. So that's why whenever three circles are given, to find the radical center, first and foremost thing is, you have to observe that, you have to verify that the given equations of the circles are in the general equation of the circle or not, you have to verify. Here first equation is in the form of general equation of the circle, but second one is not in the general equation of the circle. So that's why here second equation is divided by 2. While dividing every term you must be divided. So even constant also. So that's why x square plus y square plus 3 by 2 into x plus 5 by 2 into y minus 9 by 2 is equal to 0. The third equation is in the general form of the equation of the circle only. Using these three equations, you have to find the pair of radical axis. So then point of intersection of pair of radical axis is nothing but radical center. So like this we can find the radical center of given three circles whose centers are non-collinear.